Hey everyone, this is Meryl.
And this is Kritika.
And this is Abdul.
And we are Virginia Tech's electrical engineering students.
And this is an educational video made for the Design and Power capstone, specifically for 4th through 5th grade elementary students to teach them about electricity.
You find all the slides and worksheets in the description. Enjoy!
Hi everyone! This is the educational video for the Parallel Circuits lesson. With this PowerPoint, we'll review important concepts related to parallel circuits and then perform an experiment. So let's begin! So before we dive into the parallel circuits lesson, we're going to do a series circuit review. When all the energy or power flows through the same path, it is said to be in series. And this was exactly what we talked about in this series circuit lesson. So what is the blank in this sentence? There are blank separate paths. So in a series circuit, there are no separate paths. If you add a light bulb in a series circuit, it will cause each one to be blank and blank than before. So if we think back, as we add more light bulbs, each one will be dimmer and dimmer than before. If a lamp or a component in the series circuit breaks or stops working, the circuit is blank, and all the components will stop working. So the answer is broken. And in this picture you can see this is a complete series circuit with 3 light bulbs, and all the electrons are flowing through one loop, or one path. So now we'll discuss the basic principles of parallel circuits. When all the energy or power can flow through blank paths, this is said to be in parallel. Is it A, same paths, or B, multiple paths? And the answer is B, multiple paths. Parallel circuits are blank. Are they A, rare, so you don't see them very often, or B, it's very common in your everyday life? And the answer is B. You actually see them in a lot of different devices. Parallel paths go from the main power source and provide all the electricity and power throughout the house. So an example of how common it is that all the electrical wiring in your home is generally on a parallel circuit, because you don't want to turn off, say, your light switch and then turn off everything in the room, or you don't want to just turn off your TV and then have the lights go off. So they're all done in parallel. And now we'll talk about how light bulbs work in a parallel circuit. The energy or power moves through separate branches to light up the light bulbs. But in this circuit, or a parallel circuit, if one light bulb goes out, the others stay blank. And the answer is that they stay on. So imagine in your house, when a single light bulb goes out, does everything in the house turn off? Generally, the answer to that is that not everything turns off, and that's because your house is wired in parallel, so that if one thing breaks, not everything turns off. If you add or remove light bulbs, the brightness blank. A gets brighter, B stays the same, or C gets dimmer. And the answer is B, it stays the same. And this is one difference that you really should remember between parallel and series circuits. Because if you remember in the series lesson, we learned that if you add light bulbs in a series circuit, the brightness goes down. But then if you remove light bulbs, the brightness will go up as long as it's still a completed loop. So here's an example of when there's a broken object in this parallel circuit, but the other 2 light bulbs are still on. And this diagram shows you that the flow of electricity is all in both the inner loop and the outer loop, so both light bulbs are on. So now that we've talked about series and parallel circuits, let's discuss the differences between the two. Here's a diagram of a series circuit and of a parallel circuit. What's the biggest difference you can spot between the two circuits? Now there are a few answers to this question, but one of the most important things to realize is that in one of them there is a single loop, while in the other one there are two loops, causing it to be a different connection, or the way that the light bulbs are wired to the battery is different in both diagrams. So which one is a series circuit? Which one is a parallel circuit? So the answer is, this one is a series circuit, and this one is a parallel circuit. And you can tell based on the connection that there's only one loop in the series circuit, and then there are multiple paths that the electrons can go through in the parallel circuit. So now we'll go through some images of circuits and see if you guys can pick out which ones are parallel and which ones are in series. So here's two. Which one do you guys think is in parallel and which one do you think is in series? Or are they both parallel or are they both in series? So now before we give you the answer to this, what about these two circuits? Okay, so now we'll show you the answers. This one is in series as it goes through one path. And then this one is in parallel as it has multiple paths. And this one is in series as again it only has one path. And this one is in parallel. So finally we're at experiment time. The next section of this video will be a demonstration of how to perform the parallel circuit experiment, with just some key points to go through as you do the experiment.
Hi guys, I'm Krithika and I'll be demoing the parallel circuit experiment.
Okay, now I'm going to be showing you how to construct the parallel circuit. Ta-da! Here is the parallel circuit. Okay, so now we're going to start the parallel circuit lesson. And the first thing we're going to do is turn on the circuit. And you can see that both the green and the red LED are on. So now to move on to the next step, we follow proper safety convention and turn off the circuit. And now we're going to remove section 1. And then turn it on. So you can see that the green LED is on while the red LED is not on. So now to replace the section, and now we're going to remove section 2 and see what happens here. This time the green LED turned off and the red LED stayed on. So then, to go to the next step, we're going to turn off this circuit, replace section 2, and then remove section 3. So, once again, the green LED stayed on while the red LED turned off. So, we're going to turn it back into the original circuit and then see what happens. Like we saw before, both lights are on, and then this is considered to be a parallel circuit.
Okay guys, so just some important concepts to remember are that when we remove the branches, those sections were no longer in a full loop around the circuit, so that can be said of that individual branch to be an open loop. While on the other side it was still connected, so the light was on, and that can be a closed loop. So that's the end of our parallel circuit lab. Bye. Yeah. So that's the end of this educational video.
I hope you learned a thing or two.
And I hope you enjoyed it. Thank you for watching with us.